doubts on that? Now, what you want to do is take out, take out that other piece of notepaper. We're continuing this just a little bit more. I really should do, it's this piece of paper here. Did we do problem 5 and 6 on this, the sum or whatever? No. So take a look at this. From your notes that I gave you, the systems, solving systems by substitution here. We didn't talk about story problems. Story probs. And the first one, let's talk about that, the easiest one there, says this. The sum of two numbers is 9. The sum of two numbers is 9. The difference is 1. Okay? And I know you can do this in your head, but that's not the point. You can probably tell me two numbers who add up together are 9, and when you subtract them, they're 1. That matters not to me, because it's the process that you're going to use, because in the next one you won't probably be able to do that. And here is what you need to write down for these people. Solving simultaneous equation story problems, which is what we're talking about today, are done like this. The first thing you have to do is you need to, well, I say, define your variables. Which means you have two unknowns there. What are they? The two numbers. Okay? If the two numbers were identical, you could use the same letter for them, but they're not. You're not going to add 4 plus 4 to get 9. They can't be the same because there's no two numbers added together that give you 9. And by defining variables, I mean you need to go off to the side of your paper and do this. I am going to call x my first number, and I'm going to call y my second number. And you can pick whatever variables you want. And a lot of times in a story problem, you want to make them represent what they represent. If you're talking about boats, you maybe like it the letter B. If you're talking about dogs, you make it the letter D. It doesn't matter, but in this case, they're just two numbers. So, I mean, I could make one number N and the other one something else, but they can't be the same because they're not the same. So that's what I mean when I say define your variable. Pick the letters that you're going to use. Then you need to, step number 2, write your equations. And that just means this. The first one, which I didn't write out, sum of two numbers is 9. That means when I add the first one plus the second one, my sum is 9. The second equation says the difference of the two numbers is 1. So when I subtract the two numbers, I get 1. There's my two systems or simultaneous equations. And then step number 3, you're going to solve that. With the knowledge that you have, you could graph these on a piece of paper and guess where they'll cross. I mean, you'll know where they cross. But today we're talking about solving by substitution. So I need to solve one of these for a number. Which one? Anybody? Doesn't matter which. There's really no wrong answer, but there's certainly one that would be harder to do than the others. Anybody want to go with one? Eli, which one would you solve for what? 4. Yeah, it doesn't really matter. The only one I wouldn't say is solve the bottom one for negative y, because you just don't want your variables to be negative. So I'm going to subtract y over here. So my new equation is this, x equals 9 minus y. Put that in for x down here on the bottom. So I get 9 minus y for x minus y equals 1. Then if I put two negative y's together, I get negative 2y. Subtract my 9. What is 1 minus 9? Negative 8. If negative 2y equals negative 8, y equals 4. One of my numbers is 4. How do I figure out what the other number is? Put 4 in right there. 9 minus 4 is 5. My two numbers are 4 and 5. Does that work? If you add them two together, do you get 9? If you subtract them, do you get 1? Yes. Most other kids at this point would not, but that's okay. I know you're just a little hyped up on children. Jake says that's all well and good, but what about the second problem? Yeah, let's look at the second problem there. On your little sheet there, it says the school that John goes to is selling tickets to a spring musical. On the first day of ticket sales, the school sold 1 senior citizen ticket and 6 children tickets for $67. The school took in $109 the second day by selling 7 senior citizen tickets and 6 child tickets. What's the price of each? Well, what's the price of 1 senior citizen and 1 child ticket? Anybody got an answer for me? Perfect. So let's do this Savannah Vickery just like we would do it for real life. Step number 1 says you're supposed to do what? Define your variables. I have 2 unknowns. What are they? They are the senior citizen ticket and the kid ticket. So you need to write that down, otherwise you'll forget it. So for senior citizen, I'm going to use the letter S. Why? I don't know. This is the number of senior. Let me see how much the dollar amount for a senior ticket. Right? The other one is child ticket, so guess what letter I'll probably use? The letter C for the child's ticket. That's how much a child ticket costs. So I've got to define my 2 variables. You get to pick what letters you want. Now I need to try to write 2 equations with what I'm given. And the first equation says 1 senior citizen ticket and 6 children's ticket cost how much? So how do I make that equation? 1 senior citizen ticket plus how many children tickets? 6 children tickets cost me how much? $67. Equation number 1. Equation number 2 said that 7 senior citizens and 6 children tickets, 7 senior citizen and 6 children tickets cost me how much? $109. So here is my simultaneous / systems of equations. If I am to solve that, children, what do I need to do, Kelsey Edwards?
Take the, I would use the top and subtract the children.
Right. You want, this is the only one that has the letter by itself. A 1S is the same as S. You don't need that 1 there. So Cal says, if we're going to do it by substitution, we're going to move this 6C to the other side. I subtract 6C. So 1 senior citizen ticket is going to equal 67 minus 6C. Move that over there. And then I can use substitution because I can put this, boy, I hope this works out. I can put this in for the letter S right here and figure out what the letter C is going to be. Ready for that? Sure, why not? 7 times what S is plus 6C equals 109. And what was S? 67 minus 6C. Do you not love upper grade mathematics? 7 times 67, anybody in your head? What is it? 49, 469? Am I good with that? Minus 42C plus 6C equals 109. Stop me if that didn't make any sense. I just distributed property out. Now what am I going to do, Calvin? I am going to combine because the fields are right. What's a negative 42C plus 6C? Negative, yes, 36C. And I'm going to subtract my 469. I love this. Subtracting 469 from this is going to give me a negative, their difference, which is, no, get out of there. Scoop, get, go, okay. 9 from 9 is 0, 0 from 6. Oh, look how nicely that is. I get negative 36c equals negative 360. Solving for c, I divide by 36, divide by 36. The letter c equals, children, 10. Now what really does the letter c equal? And that's why I define my variable, because really the letter c doesn't equal just 10. The letter c was how much a child's ticket cost. The letter c is each child's ticket is 10 bucks. And then I need to figure out how much a senior citizen ticket costs. Well, I take my little $10, I would put it in right here. 67 minus 60 is a senior citizen ticket costs $7. Now, can I tell you, for those of you that think that was rather cumbersome and kind of like long and drawn out, tomorrow your eyes will be awakened to another way to do this that is much quicker and simpler and lots of less mathematical procedures than this.
Why couldn't we done that?
Because you always learn, Jake, is it easier to walk or run?
Walk.
And which one did you do first? There you go. Perfect. Got that? Bam. Everybody's happy with that. Now, what I have for you for tomorrow, you're going to do, there's a little bit of, well, no, you know what? No, let's do this. On today, take out today's worksheet. I want you to try this one. I have it all ready to go.
Yes.
Try that one for me right now. Christian's cheering because he did this one or what?
Yeah, he did it. I'll do it.
Christian, somehow that doesn't surprise me. I want you to try problem number 14. Please do not come back to my desk and say you don't know how to do this unless you've tried to define your variables.
This is the homework.
Unless you've tried, what?
This is the homework.
No. No, I've got something completely new. You did this all on your own, Christian?
Maybe.
Is that a definite maybe or a partial maybe? That's what I thought. So define, what two things don't you know? You don't know how much a blueberry pie costs, nor do you know how much a blackberry pie costs. So you're going to have to define those two variables. Write down what you're going to, and I know they both start with B, so you might have to pick something, you know. And that's why, by the way, children, that's why in math they use subscripts. Like you could do this, blueberry 1, sub 1 stands for blueberry, and you could put B sub 2 stands for blackberry. A lot of times in math people do that when you end up with this. I don't know if I would do it in this case. As long as you label them, it doesn't matter. You don't have to use letters that are the same. You could put A and B, X and Y, whatever you want. But that's why if you see in math, B sub 1s and B sub 2s, they don't mean the same thing. They're the same letter, but they have different subscripts. I'll change that later. I wouldn't use B's. I would be running. Maybe shed a little light. Give every life a little rain this fall. Oh wait, maybe I don't want this one. Well, okay, sure, let's do it. The problem with this is what? Anybody tell me what the problem with this one's going to be? When you write your equations, none of them are just a single letter. They all have numbers in front of them. Is that going to cause trouble? Well, let me try another one here. Let me see. Jennifer, yeah, 15. Do 15. Do number 15. I'll try to get number 15 up on my board here. Oh, don't show the answer. Like the answer would help you anyway. nice, because one is rose and one is geranium. I'll move the step full section. Stuck yet? Pretty good news, Mrs. Smiley is smiling.
No, I don't know, how many could they miss and still pass?
What was it?
13. 13, 12.
It's not necessarily pass, it's not have to take it again. They're still, they actually pass. Their grade is not horrible at 13, but. Who's got it?
13 wrong or left, is that what you're saying?
Something like that. 13 or less.
Well, you're all just sweating, aren't you?
Yeah.
I know, and you don't.
All right, in the interest of time here, children, this is what it would look like. You've got two equations they give you, and it's right here. Jennifer spent $84 for 4 rose bushes and 4 geraniums. So, 4 for each row, 4 rose bushes plus 4 geraniums cost $84. The second one comes here. Catherine spent for 1 rose bush and 4 geraniums, she spent $54. Those are your two equations that you're going to solve. Try to figure out. If you had a big enough piece of graph paper, you could graph it and see where they correct, but we're not going to do that. This is the logical one. You're going to subtract 4g. So R equals 54 minus 4g. How many people got that far? That was step number 2. Then it's just a matter of doing a lot of mathematical calculations, because you're going to plug this in for the letter R right there. So you write your equation 4 times what the letter R is, plus 4g equals 84. That's this thing without the little R there, which is 54 minus 4g. Distributive property, 216 minus 16g. 4 times negative 4 is negative 16. Plus 4g equals 84. The fields are ripe, so we're going to combine here. Negative 16 plus 4 is negative 12G. I'll move this 216 over there. Unfortunately, we seem to have to work with negative numbers a lot. But know this, the negative is bigger than the positive, so my answer is going to be negative. I take the difference of those two, which happens to be what? 132. And my answer will be what happens when I divide by negative 12. And I believe it looks like it's going to be a positive 11. G equals 11. And the reason you define your variables is so that you can go back and see what the letter G actually stands for. G stands for how much does a geranium cost? A geranium costs $11. A rose bush, you're going to plug the $11 into this. 4 times 11 is 44. 54 minus 44 is 10. A rose bush costs $10. And that, children, as we say it, is a per